Good morning, guys. Um, this is Brilliant Tech Tutorial. My name is Lacey. On today's video, I will teach you guys on how to solve partial differentiation using implicit functions. Now, with this flowing question, we have question one. We ask that if x squared minus xy minus y squared is equal to 0. Now we have to find the y over what the x. Solution to solve this. Now we have that if x squared minus xy minus y squared is equal to 0, we have to find the y over dx. So therefore, what you need to do is we have to equate this equation to be equal to what z. So say that let z equals what x squared minus y squared minus xy minus y squared, right? So therefore, let differentiate in respect to what z. So in differentiate, we have that differentiate dz over dx. So dz over dx means under z differentiate x. So you have the x here is you have x squared. Differentiate x squared is what is 2s, and here is xy. Differentiate xy is what differentiate x here remains what remains y. So that's the answer for dz over dx. Now again you have to differentiate what we have to differentiate y under z. So dz over dy is equals to what this is z. Where is y? This is y terms. We have to differentiate only y terms. Differentiate y here is minus 2y. Differentiate y here, it becomes minus x, right? So therefore to find the y over dx is equal to minus bracket dz over ds over dz over dy. This is the formula to find the y over dx. So this using implicit function, that is equal to minus bracket dz over ds all over dz over what dy, so which is equal to minus bracket. What's my answer for dz over ds? It was 2s minus 1. So equate that become 2s minus 1 over my dz over dy was minus 2y minus x. That become minus 2y minus s, right? So therefore, which is equal to, now if I'm to open this bracket, minus times 2s is minus 2s, minus times minus y will give me what plus y all over minus 2y minus s. Now in this equation, you know that we can still factorize the signs. So therefore factorizing the signs becomes here in the numerator we have to factorize minus. If I should factorize minus here, this becomes 2s, and here it becomes minus y. And again, if I'm times it, minus times will give me minus, this minus times minus will give me plus. So the same thing all over. Now factorize minus in the denominator, that becomes minus bracket 2y plus x. Okay, so that becomes, now minus cancel out minus, it remains only what 2x minus y all over 2y plus x. So this is the answer. Very simple. I have question number 2. Question number 2 says that if x times y is equals to y sine x, if x times y is equals to y sine x, we have to find dy over dx. Solution to solve this, the same thing. We have to do what? Equate x. Now you know that in this question, we have that if x times y is equals to y sine x, we have to find dy over dx. To solve this, now we have to bring the right hand side equation into the left hand side. So it means that this y sine x, we have to bring it to the left hand side. Okay, so in solving this kind of stuff, you have to always bring the right hand side equation into the left hand side. So this is left, this is right. So now I'll bring y sine x into the left hand side. So this becomes what x times y minus y sine x. Okay, so therefore, now after doing that, I have to equate what I go to be equal to what z. So therefore z is equal to x times y minus y sine x. Okay, so let's start differentiating. Now the differentiating dz over ds is what? So under z differentiate x. Now you know that for you in this x times y, you know that for you to differentiate x must be in front of the function, not at the back of the function. X must be in front of times y and not at the back for you to differentiate in respect to what x. So it means that x must be in the front of the function of this term function, not at the back. So since x is at the back, so the only thing I will do is to I have to eliminate x and then leave the function like this. So that becomes eliminate x here and become times y. Now again, if you come here, now x, this is balanced, x is in front of the function, that is, so I have to differentiate. So now differentiate sine x is what is called s. So that becomes minus y cos what x. Again, let's differentiate dz over dy. Now dz over dy, you know that y must be in the function y must be in the front of the function. So you check here, y is in the front of this tan function. So I have to differentiate now. Differentiate tan y is what? Is x square y. So that becomes bring down what? X. Now put a what? Minus. Again. Now I have to differentiate. If you check here, y is at the back of the word function. So mean that I won't differentiate it because y is at the back of the word function. So I didn't y is the front of this function. I'll differentiate it. So that becomes I have to only eliminate y and leave sign 1x like that. Okay. So therefore that becomes now to find therefore dy over dx is equals to using the formula minus bracket dz over ds all over dz over what dy. Okay. So which equals to minus bracket all my dz over ds. Dz over ds is tan y minus y cos x all over dz over dy is x square y minus sin x. This is this. So therefore now open the bracket. That becomes minus sin this will give me minus tan y and minus sin this will give me a plus y cos x. Okay. So therefore all over what x sec square y minus what sin x. So if I should, you know that this is something as y cos x minus tan y all over x sec square y minus sin x. So this is the what answer. Very simple. I have question number 3 says that if 2x squared plus 4xy plus 3y squared is equal to 1. So therefore we have to find dy over dx and d square y over dx square. Now solution to solve this. If 2x squared plus 4xy plus 3y squared is equal to 1, we have to find dy over dx and d square y over dx square. So to solve this, now we have to equate this equation to be equal to what z. So therefore I have to bring any number or any equation which is at the right hand side into the what left hand side. So this one will move to the left hand side. So that becomes minus 1 is equal to what z. So therefore z is equal to 2x squared plus 4xy plus 3y squared minus 1. Okay. So therefore z so therefore z is equal to 2x squared plus what 4xy plus 3y squared minus 1. So therefore we have that dz over dx. So let's start differentiating. Dz over dx is equals to differentiate 2x squared is what 4x. Differentiate 4xy is what is meant 4y. Okay. Now dz over dy is equals to differentiate 3y squared is what is 6y and differentiate 4xy is equals to what 4x. Okay. So therefore let's solve. Dy over dx is equals to minus bracket dz over dx all over dz over dy. Okay, which is equal to minus bracket my dz over dx is what is 4x plus 4y all over my dz over dy is 6y plus 4x, right? So therefore we have to factorize this. Now check the fraction, which is check what you can see in the numerator and you can also see in the denominator, which is the simple factor is 2. So minus, so I have to factorize 2 out. Factorize 2 out, here remains 2x plus 2y over factorize 2 out, here remains 3y plus 2s. Okay, so therefore which is equal to minus bracket, 2 cancel out, 2 here remains 2s plus 2y all over 3y plus 2s. Okay, so open the bracket, this becomes minus times 2s is minus 2s, minus times 2y plus 2y is minus 2y, so all over 3y plus 2s. So therefore let's factorizing this now. We have the in the numerator. What is common? The common factor here is 2. That's minus 2. That becomes minus 2 out. So therefore here becomes x. Now if you check what's common here is what is 2, right? So if you check this, if I factorize this, what's common here is minus 2. So if I factorize minus 2 here becomes what? Sorry. So if I factorize minus 2 here out, so here becomes what? This become x. Sorry. So this become what? X plus what? X plus what? Plus y. Okay, over 3y plus 2s. Or you can still leave it as factorize this. This is out. Okay. So where this is plus, right? So therefore or you can still leave it as minus 2 bracket x plus y all over, revise it 2x plus 3y. So your answer can be like this or otherwise. Please guys, if you find this video interesting and helpful, please don't forget to like, subscribe, comment and share. Thank you.